Okay, picture this. You reach for a bag of flour, maybe a box of cereal, or a packet of pasta to make dinner, only to be totally surprised by something tiny and unwanted crawling around inside, right? It is an experience that instantly makes your skin crawl. But actually, it's incredibly common. So today, we're becoming Pantry Private Eyes to investigate the most common stored product pests that invade our everyday spaces. Our kitchens are usually the primary scene of the crime, providing just a perfect all-you-can-eat haven of food and shelter for these elusive intruders.
Welcome to this explainer. I am beyond excited to guide you through this structural breakdown of household pests. We are going to use the actual science of entomology to decode exactly what might be hiding in your cupboards, how they operate, and most importantly, how to identify them like an absolute pro.
All right, let's open up the dossier for today. We'll be looking at 1. Scene of the crime, 2. The Bug Detective's Toolkit, 3. Internal feeders, which are the inside jobs, 4. External feeders, the outside operators, and 5. Dermestids, also known as the animal eaters.
Starting with number 1, scene of the crime, where pests lurk.
While we immediately think of our own human pantries at home, the reality is these infestations usually start way earlier in the supply chain. Commercial food warehouses, shipping containers, processing plants, and especially pet food aisles are massive scenes of the crime. You know that 40-pound bag of dog kibble sitting on the bottom shelf? Yeah, that is essentially a 5-star resort buffet for a whole host of crawling suspects.
Just look at the sheer variety of victims on this list. Pests aren't just after your baking flour or standard grain-based goods. They actively target plant proteins, dried veggies, nuts, spices, and yes, even chocolate. And some of them don't want plant matter at all. They are strictly after animal proteins, actively seeking out dry pet food, hides, feathers, and get this, even your expensive woolen sweaters. No way, right? But it's true.
Moving right along to Section 2, the Bug Detective's Toolkit. Anatomy for identification.
If we're going to catch these beetle suspects, we need to know 2 absolutely crucial anatomical terms. First up is the elytra. These are the hardened protective forewings that basically act like a shell covering the beetle's back. Second is the pronotum, which is this prominent shield-like plate covering the thorax sitting right behind the insect's head. So, mapping this out on our suspect's anatomy, notice the pronotum colored in yellow right below the head. And just below that, highlighted in red, are the elytra, those wing covers we just talked about. Now pay special attention to those vertical lines running down the elytra. Those are called striations. The presence, absence, or even the depth of these grooves are going to be massive clues for us in just a minute.
Next, check out these incredibly diverse antenna shapes. You guys, these act literally like fingerprints for bug identification. They range from simple thread-like or bead-like structures all the way to sharp sawtooth and distinctively clubbed ends. When you're trying to tell the difference between 2 beetles that are barely 2 millimeters long, the specific shape of their antenna might honestly be your only definitive clue.
All right, on to Section 3, internal feeders, inside job.
In the entomology forensics world, we categorize these pests by their modus operandi, the 4 distinct ways they operate. We've got scavengers that only attack processed or already damaged grains, and secondary pests that just go after moldy or out-of-condition products. But we're focusing our investigation on the primary criminals here, internal feeders, whose larvae develop entirely within a single whole grain kernel, and external feeders.
Let's pull up our first suspect lineup of internal feeders, the true weevils of the family Curculionidae. Side by side, we have the rice weevil and the granary weevil. Notice their heavy bodies and those incredibly long snouts, or proboscis, extending right from their heads. They literally use these snouts to chew deep into whole grains, completely inside, just to lay their eggs. Now, while they might look pretty much identical to the naked eye, they operate completely differently. The crucial takeaway is how they differ both behaviorally and physically. The rice weevil has closely spaced oval pits on its thorax and faint X markings on its wing covers. More importantly, though, it's an aviator, drawn to light, meaning it can fly. The granary weevil, on the flip side, has widely spaced pits, totally hates the light, and is strictly a grounded operator because it cannot fly at all.
Because these internal feeders develop completely inside the seed, they leave behind undeniable physical evidence. Just look at Exhibit A here, the bean weevil. Now, they don't have the long snout of a true weevil, but they're absolutely still internal feeders. After hatching inside peas, beans, or peanuts, the mature insect literally eats its way out leaving these highly distinct, perfectly round exit holes behind. If you've ever seen beans that look like they've been drilled with a tiny laser, you've got bean weevils.
And hey, beetles aren't the only ones pulling inside jobs. Check out Exhibit B, the Angomois grain moth. Notice the shocking internal damage this moth larva can do to a single kernel of corn. The larva develops entirely inside, eating out the entire core of the grain, before finally emerging as a small, yellowish-white moth with a half-inch wingspan. It's crazy.
Moving on to Section 4, External Feeders, Outside Operators. Okay, here is a rapid-fire lineup challenge for you. Meet the drugstore beetle and the cigarette beetle. These are tiny, incredibly common external feeders measuring only about 2 to 3 millimeters long. At first glance, honestly, they just look like tiny brown specks. Can you spot the difference between the two? The definitive proof to solve this challenge is completely hidden in the microscopic details. You have to look closely at the wing grooves and those antenna clubs we talked about to tell them apart. The drugstore beetle has elytra with distinct longitudinal grooves, those striations, and its antennae end in a loose 3-segmented club. The cigarette beetle, on the other hand, has completely smooth elytra with no grooves whatsoever, and its antennae are serrate, meaning sawtooth, with no club at the end at all.
And finally, Section 5, Dermastids, the animal eaters.
Dermastids include hide beetles, larder beetles, and carpet beetles. Unlike the pests that want your flour, these guys strictly want animal protein. Look at Exhibit C. This is the disturbing, hole-filled aftermath of a dermastid attack on a dog treat. They feed on meats, dead animals, hides, furs, feathers, and woolens. In fact, museums actually use colonies of certain dermastids professionally to clean flesh off of delicate animal skulls for display. How fascinating is that?
And here is what our suspect looks like in its youth. This is the larva of a dermastid, specifically a hide or warehouse beetle. They're super distinctive because they're cigar-shaped and absolutely covered in numerous tiny hairs called hastacetae. Now here's why this matters to us. If a human accidentally ingests food contaminated with these shedding larval hairs, it can actually cause serious irritation to the gastrointestinal tract. So they aren't just a nuisance, they are a legitimate health hazard for your pantry.
Well, we've reviewed the scenes of the crime, opened up our detective toolkit, and profiled the internal, external, and animal-eating pests that love to invade our homes. So, I'll leave you with this final, provocative thought. Based on the clues we've uncovered today, what unseen roommates are currently snacking in your pantry cupboards right now? Go grab a magnifying glass, check your flour, your beans, and your pet food, and see if you can solve your very own pantry mystery. Thanks for joining me on this explainer.